Good morning, guys. So obviously, or I guess, hey, hooligans. So obviously this is not how we would normally be doing our lessons, but the internet is acting a little crazy. So here we are. I am going to be reading you the study guide because some of the information is stuff that I obviously would be wanting to teach you about. So I'm going to read over the study guide for science. So that way if there's any tricky words or any unfamiliar topics, you will be able to listen to me read it, and you'll also have a copy of this study guide attached to your assignment, so you'll be able to use this video and this attached study guide to complete your assignment successfully. Before we begin, I really miss you guys, and it really is no fun that Google Meet is not working, but I miss you guys, and I know we'll talk soon, so keep that in mind, that I love you and I miss you so much. So please work really hard on your assignments because they are for a grade. Just saying. Okay, so we talked before we let out for break about mountains, and we talked about some vocabulary that has to do with mountains. So we are talking about in science this week, landforms, rocks, and soil. So I'm going to go ahead. I'm just going to start reading. It says, use a special map. When you want to see and understand landforms, the best type of map is a topographic map. Topographic map. A topographic map shows many features of the landscape, such as water, roads, and landmarks, but also uses contour lines to represent precisely the size, shape, and elevation of the land's features. So that you'll see a picture of it on your study guide if you open the study guide. Go ahead and split your screen if you haven't already, so that way you have the study guide on one side and me reading it, in this video, on the other. So you can see we kind of looked at one of those when we were reading our book, Mountains. We saw one that kind of looked like that. It was of Hawaii, so we saw kind of like an aerial view or like a view from the top down. So you'll see that you can see the size, shape, and elevation means how tall the land's features are. So what are landforms? Landforms are features that make up the Earth's surface. They include mountains, plateaus, canyons, deltas, hills, valleys, and more. A topographic map of an area shows them all. Now let's review the basics, the things many landforms are made of: soil and rocks. So real quick, mountains we talked about last week. Plateaus are basically mountains that cut off at the top, so they're flat at the top. Canyons, think about like the Grand Canyon. It's like a giant dip in the earth. You know what hills and valleys are. So a hill is just like a small mountain, and a valley is like a small dip. Okay, so it says lesson checkpoint. What is a topographic map? We already talked about that. It shows many features of the landscape. Okay, so we are going to talk about soil and rocks. So life-giving soil. Soil is the loose material that covers much of the Earth's surface. There are 3 main layers of soil, starting from the top. Topsoil, which is the soil we walk around on, and the soil in which the plants and trees grow. Subsoil, and even deeper below, is bedrock. So we're scrolling down to the next page. What about rocks? Rocks are made up of many tiny pieces of minerals. Minerals are natural, non-living crystals that make up rocks. Types of rocks. Did you know that there were different types of rocks? Keep listening. Okay, so there are 3 different types of rocks. So the first type of rocks is the igneous rocks. Listen, Miss Shelton's going to use her reading skills, but I am also an imperfect human. So these rocks form when melted rock cools down and then hardens again. During the cooling stage, crystals form. So we talked about how mountains, how the rocks at the top will expand whenever it gets hot and contract whenever it gets cold, but then there's already frozen water in there. So kind of think about that. So this melted rock cools down and hardens, and then during the cooling stage, these crystals form. So the second type of rock, it says sedimentary rocks. form when layers of rock settle on top of each other and then harden together. The third type of rock is the metamorphic rocks. These form when solid rocks are pressed together and heated. The extreme heat can change the properties of the rocks being squeezed together. All right. And then the rock cycle. So you might have heard about the water cycle in different grades, or like the life cycle of a plant. So this is the rock cycle. The rock cycle represents the process of rocks changing into different forms over long periods of time. Rocks can change from one form to another and back again. So you'll see those three different kinds of rocks, and then it says like sedimentary, if you put heat and pressure on it, metamorphic, and then if you melt it, it just goes around and around and around, and you see little arrows in between. So take a second to kind of really study that map of the rocks, of the rock cycle. Okay, weathering and erosion. Erosion is the wearing away of the Earth's surface by rain, wind, snow, and ice. There are two kinds of erosion. Mechanical weathering is the breaking of rock into small pieces because such things like gravity, wind, rain, and ice. Chemical weathering is the changing of material in a rock through a chemical process. Erosion can occur quickly, as in a landslide, or it can happen slowly, as in a slow-moving river. When water moves in rivers, ocean currents, tides, and floods, it moves particles of soil and rock from one spot to another. Rain causes erosion too. Rain can move soil downhill off of fields. Farmers obviously need soil to grow crops, so they try and do what they can to stop erosion of their fields. Farmers plow across the fields to do this. The spaces created by plows catch rainwater to keep it from rolling off their fields and taking soil and other particles with it. Deposition. Deposition is the laying down of pieces of the Earth's surface. When all that water moves particles from one place to another, When all that water that moves particles from one place to another slows down, it no longer carries the sediment along with it. Instead, the sediment begins to fall to the bottom of the river, ocean, or whatever the water is carrying it. Pieces of the earth can move in other ways too. Faults. Faults are rocks, fractures, or cracks in the earth's crust which are caused by the movement or shifting of the earth's surface. Then it says types of faults. So there are 3 types of faults. So the first fault, if you look at the diagram, the first fault in the diagram 1 is a normal fault. So the 2 pieces, just one shifts down. One just shifts on down. And because they're pulled apart, so it just kind of pulls down. The second fault in the picture is a reverse fault. So instead of the earth splitting apart and then the pieces kind of falling down, the earth is pushed together, and so it's kind of pushed up. This piece of earth is pushed up. The third fault in the picture, in picture 3, is a strike-slip fault. So that means that the pieces of the earth are moving this way. So they're moving against each other left to right. All right, plate tectonics. We know that the earth has 4 main layers: the crust, the mantle, the outer core, and the inner core. The crust and part of the mantle make up the top layer of the earth, but it is not just one big whole piece that covers the earth. It's more like puzzle pieces put together that cover the earth. These pieces float on top of the hot liquid of the lower part of the mantle. These pieces are called tectonic plates. The plates under the ocean are called oceanic plates, and the plates under land are called continental plates. The area where one plate meets another plate is called a boundary. These pieces do move very slowly, of course. They slide up, bump into, and scrape against each other. When the pieces move, they cause changes to the earth. Slow changes caused by plate movements can occur over long periods of time, such as the formation of mountains. Plate movements can also cause rapid changes to the earth. Think earthquake. We're almost done, guys. How do earthquakes happen? We're on the last page. Earthquakes usually occur where two plates bump into each other. What most often happens to cause an earthquake is that two plates bump into each other and their edges get stuck together, but the rest of the plates keep moving. Soon the plate edges finally unstick. Hold on, lost my spot. Soon the plate edges finally unstick and an earthquake occurs due to the energy released as the plates unstick. This energy shoots out in all directions, causing seismic waves to shake the ground as the waves move to the Earth's surface. The spot on the Earth's surface directly above where the earthquake occurs is called the epicenter. Last section, volcanoes. And we talked about volcanoes a little bit last week, or a week before last. A volcano is an opening in the Earth's crust through which lava, ash, and gases erupt. Under the Earth's surface are magma, melted rock chambers. These chambers are like pools of magma. Above these magma chambers are channels, like tunnels, that lead to openings in the Earth's surface. As magma moves under the Earth's surface, bubbles made up of gas form inside the magma chambers. These gas bubbles cause the magma to rise. When the bubbles get bigger, the magma rises and rises until the magma is forced through the channels leading to the Earth's surface, causing the volcano to erupt. It says, note, when magma is above the Earth's surface, it's called lava. Okay, we're done reading. Woohoo! So, be sure that you go through and answer each one of those questions and make sure that you use this video. If you need to come back and use the study guide, use the study guide. Make sure that you're really, really trying your best, and hopefully I will see you on the Google Meet soon. Mwah!